Okay, objective 5 is find the equation of a line given 2 points. So step 1 is going to be to use the point slope form of the equation of a line. Step 1 is going to be to find the slope using the formula m equals y2 minus y1 over x2 minus x1, and then use the point slope form of the equation of a line using either one of the points. So find the equation of the line in point slope form containing these 2 points. So I'm going to have m equals the y-coordinate after minus the y-coordinate before over the x-coordinate after minus the x-coordinate before, and I'm going to get 1/5 as the slope. Then it doesn't matter which point I use. I'm going to use the second point because it has both positive values. So I'm going to say y minus 5 equals 1/5 times x minus 2. And that's my answer in point slope form. I can see that the slope is 1/5 and the 0.25 is a point on the line. Note that if I had used the other point, I would still get the same equation of the line. You can't have two different equations for the same line. They might look different, but they're algebraically equivalent if they're talking about the same line. Okay, so then write the equation of a line in slope-intercept form. This is one of those things that even people who haven't had algebra for a long time seem to remember, that the equation of a line with slope m and y-intercept b is y equals mx plus b. So in an equation like this, the m and the b are constants. In a given problem, they will be numbers, and the x and the y are the variables. So let's use the equation from the previous problem and write the equation for that line in slope-intercept form. So I'm going to have y minus 5 equals, I'm going to distribute the 1/5 and get 1/5 x minus 2/5. And then I'm going to add 5 to both sides to get y equals 1/5 x. Then I have negative 2/5 plus 25/5, so it looks like plus 23/5. So can you check this? You sure can. Plug in 2 for x and make sure you get 5 for y. And then plug in negative 3 for x. Make sure you get 4 for y. And so I'm going to ask you to try writing this version in slope-intercept form and see if you get the same thing. Okay, objective 7 is identifying the slope and y-intercept of a line from its equation. So if the equation of the line is already written in slope-intercept form, which is the y equals mx plus b, it's easy to see what the slope, m, and the y-intercept, b, are. So that's how it gets its name, the slope-intercept form. And notice that it's solved for y. So if the equation of the line is not in slope-intercept form, you're going to use algebra to put it in the form and then identify the slope and the y-intercept. In slope-intercept form, the variable we solve for is the y. Okay, so we need to find the slope and y-intercept of the line 3x plus 2y equals 6. So I'm going to subtract 3x from both sides because I'm trying to solve for y or isolate the y. And I know I want the slope-intercept form with the x term first, so I'm going to choose to arrange them in that order. Now I need to divide both sides by 2. So I'm going to get y equals negative 3/2 x plus 3. And then we also need to know how to graph a line using the slope and the y-intercept. So we start at the y-intercept, remembering that this is actually the point 0, 3, and labeling our axes. So 0 in the x direction, 3 in the y direction. Then this is a negative slope, so it tells me go down 3 over 2, down 3 over 2, down 3 over 2, or up 3 backwards to the left 2, and get a bunch of points that are on the line, and then very precisely use the straight edge to connect the line, the points on the line, and draw it as a continuous line, remembering that it's a whole bunch of points. Okay, so objective 8 is to graph lines written in the general form using intercepts. So the equation of a line is in general form, or it's also called standard form, when it is written as capital AX plus capital BY equals C. So again, the A and the B and the C are constants. In a given problem, they are numbers, and the X and the Y are variables. So A and B can't both be 0, or that doesn't even make any sense. And this is really only a good method if A and B divide evenly into C. And let's see if you can see why. Let's look at 2x plus 3y equals 6. So what this method says to do is find any x-intercept, and remember from the previous section, we do that by setting y equal to 0. So we say 2x plus 3 times 0 is 6. So when y equals 0, then x equals 3. So the point 3, 0 is a point on the line, and in fact is the x-intercept. Then if we want to find the y-intercept, we set x equal to 0, and we say, let's see, that's going to happen when y is 2. So when x equals 0, then y equals 2. So 0, 2 is the y-intercept. So do you see why capital A, which was 2, needed to divide evenly into the 6? That happened where? That happened here. Whoops, sorry. In this one. And then the 3 divided evenly into the 6, that was important here. So if they don't divide evenly, if you have 5x plus 6y equals 11, don't use this method. It stinks. And you'd have to be trying to find 11/5 and 11/6 on your graph paper, and it would be horrible. So this is not a good method unless the coefficients on the A and B divide evenly into the C. So here's a couple that, one that works and one that doesn't work very well, but you'll see in your homework they have you do some funky ones. So first let's find the x-intercept by setting y equal to 0. And I actually do it like this. I say x and y. Let me set y equal to 0, and hopefully you could do this in your head. When y is 0, x is 2. And then when x is 0, y is negative 3. So the point 2, 0 has to be on the graph, and the point 0, negative 3 has to be on the graph. And then if you need more points, you can see that the slope is up 3 over 2. So go up 3 over 2, up 3 over 2, and make more points, as many as you need, to make a really precise straight line. So that's the intercepts on the graph, and usually I'll ask you to label them with their coordinates. Okay, so let's look at this next one. And like I was saying, this one's going to come out funky, so it's really not going to be that useful. When x is 0, that one's easy. When x is 0, y is 6. So I can find the y-intercept pretty easily. But when y is 0, x is going to be 18/5. I don't even want to try and figure out where that point is. So instead, you need to have more than one technique, because if you only have one, then sometimes that's the hard way. So here I'm going to solve for the y. and divide both sides by 3 and see that y equals negative 5/3 x plus 6. So my slope is down 5 over 3. Down 5 over 3. So I do at least go back and make sure that my x-intercept, let's see, should be between 3 and 4. It should be about 3 and 3/5, and that seems reasonable looking at my picture. So have more than one way of drawing graphs of lines. Use the intercept method if it's a good method, but don't use it if it's not a good method. Okay, so now let's find equations of parallel and perpendicular lines. So two, again, non-vertical lines are parallel, and if and only if says this theorem goes two directions, both ways. If and only if their slopes are equal and they have different y-intercepts. So you have two lines that their slopes are the same but have different y-intercepts. So this is actually two statements in one. If two non-vertical lines are parallel, then their slopes are the same and they have different y-intercepts. That's what we would call the forward direction. That's the if. But only if is if you go the opposite direction. You say if two non-vertical lines have different slopes, have the same slopes and different y-intercepts, then they are parallel. So do you see that it's saying parallel implies equal slopes, and equal slopes implies parallel. So either one gives us the other. So how do we actually show that two lines are parallel? We have to show that their slopes are the same. So find an equation for the line parallel to the line y equals 3x. So my slope is negative 3. So for a parallel line, my new line has a slope of negative 3. And it needs to contain the point negative 1, 2. Well, let's use the point slope form of the equation of the line to get it. So it's going to be y minus 2 equals negative 3 times x minus negative 1. But this has to use either the general form or the slope-intercept form. So this is the point slope form. Y minus 2 equals negative 3 times x plus 1. If I solve for the y, add 2 to both sides, and get y equals negative 3x minus 1. Then this is the slope-intercept form. And then if I put the 3x plus the y equals negative 1, that's the general form. So either of these is fine, but you can't leave it in slope-intercept form because of the way the instructions are written. Okay, and then the last thing is perpendicular lines. So two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. So we know these are two phrases in one again, and so if we're going to figure out whether two lines are parallel or perpendicular, we're going to find their slopes. So in this problem, your first slope is 1/2. Your second slope is negative 2. If you do the product of 1/2 and negative 2, you get negative 1. So these lines are perpendicular. Now let's do the rest of these in class together.